This is Mr. Martin. These are video notes for Unit 1. We're still on Unit 1. We're talking about inverses, logarithms, exponentials. So today we're going to be looking at key features of logarithmic graphs. So we've got our learning targets. Sketch the graph of a logarithmic function. And you can identify the key features of a logarithmic graph. So we're going to be talking about domain, range, asymptotes, and then some limit behavior as well. So talking about limits, this is a calculus concept. So make sure if you have any questions that you're asking me, pause the video at any time to write down your questions so you don't forget to ask. But before we get started with the video, if you want to work on the front page here, these are some review problems to work on. So you can pause the video and work on these, but make sure you have these completed by the time you get to class so we can check in and make sure we're all on the same page and you're all caught up with these. So pause the video now and work these out, and then when you continue the video, we'll start on page 2. Alright, so moving on to the key features of log graphs. You can see here for the first problem we've got f of x equals the log base 10 of x. And the behavior that we're looking at is the domain, the range, asymptote, and then we have this weird limit notation. We have this limit and we have an x with a little arrow and then a plus sign at the top of it, which looks sort of like an exponent. And then we have the limit as with this arrow here and the infinity sign. So we'll talk about those in a minute after we talk about domain and range. But again, if you have questions about all this new notation, it's really important that you ask. Okay, so we've got our graph here. And when we talk about our domain, we're talking about the possible x values that we can use on this. And there's two ways you can think about domain. You can think about what are the restricted values that we can use when we substitute x into here. And we can also look at the graph. And personally, I think the graph helps us better. It's easier to see. If we look at the graph, we can see that the graph is actually approaching the y-axis here. But it's never really going to cross, which means that we're never going to have any x values that are negative, which would make sense because if we think about putting a negative number in here, what that would mean is that we're raising 10 to some number and getting a negative. There really is no way to take a number and raise it to an exponent and get a negative answer. If this 10 was negative, maybe, but taking a positive number and raising it to an exponent, again, there's no way to get a negative number. So for our domain, and if you've learned a different way to write domain and range, feel free to do that. We're just going to write it this way. We're going to say x has to be greater than 0. Okay, so that's our domain, that's our x values, and we can see that our graph doesn't go past the y-axis. We're not using any values of x less than 0. So that's how we would write our domain. Now for our range, if we look at our graph here, it's going to continue down forever. And as we go to the right, we can see that the graph is getting higher and higher very, very slowly. But as we continue to go out to infinity, the graph is going to keep getting higher and higher. So really there are no restrictions on the values of the function that we're going to get out. So for our range, we really have all real numbers. I like to use this symbol for all real numbers. All real numbers. And for most of our log graphs, we're going to have similar ideas for the domain and the range. Now, I mentioned this already, but as we get closer and closer to 0, this graph is getting closer and closer to the y-axis. So the y-axis is actually an asymptote, and we like to write our asymptotes as the equations of lines. So the y-axis is actually the line x equals 0. Okay, that's our y-axis. And now we're ready to talk about this limit concept. So the way we read this first statement is the limit as x approaches 0 from the positive side. Okay, so as I approach 0 from the positive side or from the right, so I'm approaching 0 coming from the right, so I'm actually traveling to the left. So as I get closer and closer to 0, we can see that I'm going to keep going down in the negative direction. We know that the x equals 0 is an asymptote, so we're never actually going to get to the y-axis. So my y values, the values of my function, are going to be getting closer and closer to infinity in the negative direction. So we would say negative infinity. Now, for the purposes of this course, we're going to talk about limits being equal to infinity or negative infinity. Just keep in mind that in some areas of study, if you're approaching a limit that's infinity or negative infinity, we would actually say that it does not exist, because limits can be defined as real numbers only, and if it doesn't approach a real number, we would say it does not exist. But for our class, we'll talk about infinity or negative infinity being limits. Okay, so moving on to the next part. So now the limit as x approaches infinity. So now we're going the other way. Our x values are getting larger and larger. What's happening to our y values? Well, we kind of talked about that already when we talked about the range. The y values are going to continue to go up. They're going to go up slowly, but they are going to keep going up. And as we approach infinity, the value of our function is also going to approach infinity. And most of our log graphs are going to exhibit this same behavior. So once you do a few problems, you'll get the hang of it. Now might be a good time to pause the video and write down some questions you may have about this first example that we did. So let's move on to the second example. You could see here this one's been transformed. We've shifted it 4 units to the left. So now when we talk about our domain, in the first problem we only used values greater than 0, but since now I've shifted it over to the left, I'm going to use values where x is greater than 4. Okay, same type of shape that we had in the first example. I'm going to get out all values of y down to negative infinity, and then as I go out to the right, my y values will be approaching positive infinity, so my range is going to be all real numbers. And where the first example, the y-axis was an asymptote, x equals 0, now we've got this asymptote over here. Okay, I know it looks like it crosses, but it doesn't. It's going to approach that. So now we're going to have an asymptote here at x equals negative 4. Okay, I know the equation of this is x equals because it goes through the x-axis. All right, and let's look at our limit behavior. So we have the limit as x approaches negative 4 from the positive side. So we're traveling along the graph this way. As we approach negative 4 from the positive side, what are my y values getting close to? And we can see that they are approaching negative infinity. As we get closer and closer to that yellow asymptote, I can see that my y values are getting smaller and smaller. Again, it's hard to tell that it doesn't cross, but it won't cross. And then we're going to look at the limit as x approaches infinity. So now we're going to be going this way. As my x values get larger and larger, my y values are going to get larger. Again, they're going to get larger slowly, but as we go out to infinity, my function values are going to approach infinity as well. So that's the first 2 of these. Why don't you go ahead and pause the video and see what you can do with the next 2. Again, we have some transformations here. One of these has actually been reflected. see what you can do with those. We'll go over them when I see you in class, but give those a try. And then when you finish with that, you can start working through a few of these if you like, and when we get to class, I'll have solutions for these as well so that you can check, and I will be able to answer any of your questions. So again, write down those questions so you don't forget, and we'll see you next time.